Um, so my name is Dvir. I work for Redis Labs basically as the modules guy in the past year. And it's been quite a year. I think Redis 4.0 hasn't been released yet, so maybe the full impact that modules, I believe, are going to have on the world hasn't been felt yet. But we're just like, arming and preparing cool stuff this entire year and working with Salvatore on the API and all the stuff that's involved in this has been very exciting and interesting. So I want to give a short overview of what we've done, what we're going to do, and again, how we're preparing for world domination with modules. So, quick recap, what's Redis? Basically, historically, Redis is a data type, data structure server, right? So you got a bunch of data types, strings, bitmaps, lists, sets. You all know them. If you don't, please brush up your knowledge because using Redis just as a key value data store sucks. So, so this is Redis historically. And you can do a lot of stuff in with Redis. Ishai earlier showed how you can do pretty advanced stuff with Redis, and it's all cool. But sometimes you want Redis, to do a bit more. I tried to model on top of Redis basically all of these things that I'm showing right now, from full text search to secondary indexing, graphs, time series. And usually it works, but then you find out that it might consume more memory, or it might be limited in some features, or it might be too slow, even though if you're comparing it to emulating this on a SQL, it's always orders of magnitude faster. And sometimes you want a new feature in Redis, so your choices are basically to convince my esteemed colleague Salvatore to do this feature, which happens like extremely rarely. It's like once, I don't know, probably happens like once every 2 years or so. Or you can fork Redis. And it sounds like a reasonable approach, but the graveyards are full with people who thought they could make this work, and it never does. And I'm speaking as one. And of course, you can build your own database, which is the hardest, but actually might be, in terms of success ratio, might be the best option so far. So why can't you just extend modules? And the idea has come up as early as Redis 1.0. That's almost 8 years ago. And Salvatore already back then had the idea of adding plugins to Redis. But that didn't happen for many years. So fast forward to 2016. We began discussions almost a year ago from now, Redis Day TLV last year, and it soon appeared that modules are going to be the main features for Redis 4.0. And the reason why it happened this time and not before was that Salvatore's figured out how to do this with an isolated API and ABI and API backwards compatibility. ABI means the application binary interface. Basically means that if you compile a module now, you'll be able to load it into Redis 5 or 6 years from now, and it will just work. And an isolated API is important because even though the Redis API from the user's perspective is very stable, from the inside it gets broken all the time and things get replaced. So if you start writing code that interacts with the internals of Redis, you're going to have to chase updates and update your code with each Redis release, and it's going to have a big toll on Redis module developers. So these two principles, once there was a concept of how to achieve them, allowed this to happen this time. And so we began our journey. Salvatore started work on it. He remembers it was on the flight here. I remember it was on the flight back, but somewhere on a plane, basically. And we had like a couple of weeks later, we had a working, first working module. And although it couldn't do much, you could add commands to Redis and register them. And you could call Redis as if you were a Lua script, but it was in C, and it was fast, and we could do stuff, and it was awesome. Like, finally, no more implementing all sorts of contrived solution on top of Redis on the client side, or bulky Lua scripts that are hard to debug. You could finally actually add real features to Redis. And even though the initial API was really primitive, it was already a huge leap forward. So the first iterations of the API, we kept it secret for 2 months, and I'm not sure it was such a great idea, but it was the idea at the time. So we had Redis command handling. Again, the Lua-like API, you could just call other Redis commands. And the coolest thing was that you can have direct memory access to Redis strings, which basically means that think that you have a string of 10 megabytes and you want to basically use that as a data structure because it's C, you can cast anything to anything. You don't have to read this string to your client or do anything with it or copy it. You can basically get a void pointer to that and just start working on it. And it doesn't matter if the string is 1 megabyte, 1 kilobyte, or 1 gigabyte. You can just start implementing your stuff on it, and that's what we used to do complex stuff initially. And you already had replication control, and then there was added a low-level, faster API that instead of just like calling a Redis command, you actually get like to touch the Redis internals in an isolated way. You have a sorted set. You can start creating iterators on it. You can push to lists, etc. And it was about 100 times faster than the high-level API, which basically uses a fake client and serialization for anything you do. So even though there's no network overhead, you're still basically a client that's calling commands and using the Redis protocols to communicate with Redis. It's very flexible, but you pay a price in CPU. So we started experimenting with modules. Initially, we started to implement some missing commands that were not part of the API, but we always wished we had. Like hgetSet, which is basically an atomic get and set from a hash, prepend to a list, delete by pattern, etc. We did some experiments with stuff that's a bit more complex, like an image manipulation module, where you could basically load an image into Redis, save it there, and then you can request the thumbnail of that image or crop it, and instead of loading that into your server, starting to treat it inside the server and then serving it to user, all of a sudden you could do, basically it's a linking against image magic. So you can manipulate the images that are stored as blobs on Redis, which was really cool. And Yossi just added a PAM authentication module and a bunch of other stuff. And the most important module in this first iteration was the obligatory leftbed. Like every modular system needs a leftbed. We've seen that in Node.js, and it was very important for us to get this right at the beginning. Then we started to get serious. We wanted to do more complex stuff and not and stop playing around. So Itamar, he didn't present himself. The guy who was like hosting this event and presenting the speakers. So he started working on probabilistic data structures like a Bloom filter, streaming top K elements, streaming distributions, all sorts of algorithms that let you estimate counts and distributions and buckets and stuff like that on like a stream of data set with low memory overhead, which were really useful. And I started working on a full text search engine, which on and off I've been working ever since on, and it's a pretty cool project. So Redis search, first iteration of it. Let's remember it for a second. So I started writing a search engine from scratch because I'm weird like that. I like to write search engines from scratch. That's my, perversion. It used, we didn't have data structures in Redis back then, so it used string DMA, again, the feature that you can just get the pointer to Redis string inside Redis for holding compressed index data, and it allowed me to do stuff that modeling an inverted index in Redis. I did that before. I actually lectured about it in last Redis Day. I don't know which of you were here, but I did it last year, and suddenly it allowed me to do it in like 10% of the RAM consumption and do things like exact phrase search, etc. And added stuff like stemming and a lot of other stuff, and then I benchmarked it, and it was like 5 times faster than the Lucene counterparts. Now, of course, it's not nearly as feature-rich, bloated as everything that's in the Lucene world, but it does a lot of stuff already, and it's pretty fast already. So, and it's not only because it's in memory. Like a search beyond like, okay, a single word is a pretty CPU-intensive thing. So modeling that in C in a system that doesn't have garbage collection also has its advantages. So just a demo, we're all talking about modules, etc. But if you haven't used it, you haven't seen a module yet, right? So just a demo of how you use search. Basically, I'm wrapping it in client libraries, but this is just the raw Redis protocol. So you start by creating, can you read this? Yeah, all right. You start by creating an index. So in this case, we create an index for products, and we define a schema. In this case, the title is a text field, and the price is a numeric field. And it doesn't mean actually that the documents have a strict schema. Documents can have as many fields as they want, and but the index just looks at these fields and indexes them. The objects themselves, the documents themselves, get saved in ordinary hash keys in Redis. You can actually even index existing hash keys in Redis, and again, the index just cares about the part of the hash that's a schema. Okay. Now let's add a product. So we add product, we give it an ID and the rank for which in this case is 1, but you can apply page rank or time rank or whatever around here. And we give it the fields are the title, LG 42-inch LCD TV. The price is $500, let's say. Okay. And then we add another one. This one is a Toshiba 40-inch TV, and the price is $400. So they were both added. You can access them with hgetAll, although if you do change them, the index will not reflect that automatically. You need to re-index them. And now we search. So in this case, we're going to do a slightly complex query. We search for an LCD TV. But we filtered the price to be between $450 to infinity. It's the exact same semantics as ranges on sorted sets. You can also have like braces to imply excluded range, and then we see that we have just one result, and it's ID 1, blah blah blah. And by the way, you don't have to actually store the documents inside the Redis's hash objects. You can just update the index, and it will just return IDs, and then you can have your objects stored anywhere you like, in another Redis instance, in a SQL database, wherever. We don't care. And then Salvatore developed the second iteration of the modules API, which allowed us to do more interesting things. We could actually create data types now. So we didn't have to hack it on top of strings anymore. So basically, the famous try that Salvatore mentioned earlier began as a module data type. and it allows you a much greater degree of freedom. You can, and actually makes the code more testable, because now you can test your data structures outside of Redis, and they're independent, and it's really, it makes life way easier and keeps the Redis API just as like this thin layer on top that binds everything, but underneath it's just your basic C library or application. And then there was added the ability to block the client and work in the background, which means you can do heavy computation while the client is waiting. And since Redis is single-threaded, you can actually do heavy stuff now and not block Redis, which you couldn't do before, especially like with Lua scripts. They block Redis while they run. So, and modules as well, but with this API, you don't have to. So here's what happens when you work asynchronously. You have like pointer, can you see? All right, so we get the first request. It enters here. We have like a module thread that's completely disconnected. The modules can use thread pools or whatever. Redis doesn't care. You enqueue some background work on this thread, and Redis right now blocks the client but releases its own event loop. And now another request that is blocking for, let's say, or very short, enters Redis, and it gets handled. When you finish your work, you tell Redis to go back to the main thread with another callback. Pretty similar to the way UI toolkits work. You know, if you've worked with Qt or the Android UI, it's basically the same. You can't do, or you don't want to do blocking stuff from the UI thread, and you can't update the UI from other threads. So it's basically the same concept, and it works really well. The first implementation for that, and the reason for that probably was Salvatore's neural network module that was doing the training in a background thread. So this allowed some interesting stuff. I've added the autocomplete for search. We started working on machine learning models. I'll get to that in a second. Salvatore wrote his neural Redis, and I started writing a secondary index that's separated from Redis itself. So Redis ML is an interesting concept we've been working on inside Redis Labs. The idea is this. In the machine learning model world, like you have all those frameworks and libraries, and they're usually focused around the training phase, right? Like the GPU stuff and all the TensorFlow and everything. They're focused around processing the data and building a model. But besides TensorFlow, most other frameworks, once you're done, you're just like on your own, build your own server infrastructure, serve that stuff. Sometimes you have to pre-cache all the results in advance, like probably my friend here knows. So there exists this whole, which again, compared to the problem of training convoluted neural networks, is not a huge problem. But again, it would be cool if you would have a database for machine learning models. So we did that, and once you train your model, and you can do it in whatever framework you prefer. Our go-to framework is Spark. You store, instead of just like storing it in a database and then loading it, or performing batch classification in advance, you just store it on Redis, and then Redis not only stores the model, like if you have something like a random forest, it's not like stored in rows. There's actually, Redis stores a random forest in memory, and then you can just give it a feature vector, and it returns the result of evaluating the model, and it's extremely fast, again, because it's C and not Java like most of this world. And again, and even if you have to scale your model to more than one server, then this problem becomes more than a nice to have, and it actually becomes a hard problem that we want to solve. So Redis ML, yeah, it's in initial phases, but it already has tree ensembles, which is basically random forest, linear regression, logistic regression. It has like row matrix and vector operations that you can do like in a lower level, and we're working on more stuff there. So that's a cool module. And neural Redis, which Salvatore mentioned before, so I won't get into that. too deeply, but it's a really, really nice module. Another one by Itamar is ReJSON. Now, a lot of people use Redis for JSON, but it sucks. You just save it as strings, right? And let's say the common pattern I know is saving user sessions. So you got the user session, and then you need just the token, or you need to update the last access time of the user. What you need to do now is to load all that data into memory in your web server, update it, and save it back, right? It's still faster than Mongo probably, but you don't want to do that. Because we don't get atomicity, and if the document is really big, then you're not faster than Mongo. But still, a lot of people are doing that, and we thought it would be cool if Redis could manipulate JSONs or query JSONs directly. And I won't go too deeply into that because I don't want to steal Itamar's thunder, and he'll be giving a much deeper dive on it later on. But the idea is that Redis now stores the documents not as blobs, but as actual document trees. And then you can update parts of the document. You can retrieve just parts of the document, delete, append to list. So as you can see here, we're just saving a small JSON here. And then we set another element in this dictionary. We have foo and buzz, and we set goo. And then we incur by the first element here. And then we get just this array. And then we can get the entire JSON. And again, if you just want to update the user access time, you don't have to load the object at all. You just update, increment, set, whatever. And it's way, way, way faster. Itamar will probably show benchmarks, right? All right. And another interesting one we did is Redis secondary, which is a schema where secondary indexes, not full text indexes, more of what you might expect from SQL secondary indexes. They can either be used directly as row data types in Redis, which can actually index other stuff, or you can automatically treat hashes in Redis as though they were table rows or objects, and index them and query them. And I've built a small subset of SQL language to provide where clauses and actually query Redis. And the concept was that I didn't want to go full SQL. I wanted to keep Redis. So even though you have where queries, they're just proxies to ordinary Redis commands. So you say, this is the index. I'm going to use it where blah, 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 blah. And now I want to do hgetAll, hset, incur by, whatever. And it just takes the first half of the query, gets a bunch of IDs. And then for each of those IDs, it applies the operation you wanted to do. And so it still feels like Redis, but you can do stuff that otherwise would require tons of work to do. And trust me, because I did it 3 times as a client-side library. So here's an example. We create an index of users, name and age. Type hash means it can index hashes. And the schema is that the name is a string and the age is a 32-bit integer, because we have people who are 4 billion years old, and we don't want to discriminate. And then, as you can see, there's a command index into, which is the write command. And then we say, using this index, basically, HMSet user1 with the name and age. Again, another user. And now I can use the where. So index from. By the way, these commands operate the same. The only reason there's 2 commands is that we want to be able to disallow write commands on slaves. So I separated it into 2 commands, so you can have like a bigger degree of control of what's a read and what's a write. But inside they operate exactly the same. So from user's name, age, where name like be whose percent hget, and as you can see, I'm substituting the found ID with a $sign. All right, and I just want to get the name. So it just returns user one, Bob, you get the ID and the property you wanted. And then again, it can be complex queries. In this case, name greater or equals than Alice, and the age is less than 31, and I want to just do an age get all, blah, 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 you do an age get all. So as you can see, it's also very familiar if you're working with Redis, but it's also something you couldn't do until now. And it's implemented way more efficient in terms of memory and CPU than doing that with a sorted set, which is what you usually do for this. Another thing we did this year is we started small. It's not anything big yet. We want to start and nurture a module ecosystem. So at RedisConf in May, we started this website called Modules Hub, where we both put our modules and people can submit their own modules, and we publish them if we see fit. Again, we have big plans for it, but so far it's just like, you know, a preview of modules, a preview of what this thing can do. In my imagination, eventually it can become some sort of an app store for Redis modules. We also had a hackathon, global distributed hackathon with on-site events in Tel Aviv and San Francisco. There was some very interesting stuff did there, and we gave cash to the winners, and they did cool projects. The winner is a project called Redis Cell, which is some sort of fancy rate limiter written in Rust. Now, I have to say, I was on the judges panel. I didn't want this project to win, but it was still impressive. And what made it win was the fact that it was already ready for production. Whereas other modules were just like, you know, half implementations or very, very ambitious things that were not nearly ready. But it's also a very useful and very non-trivial throttling algorithm that you can tune a lot of parameters in, and it's a really cool project. You should take a look at it. A bunch of other stuff. We had notable mention is the Redis Graph by Roy Lippman, who is now Redis Labs employee. And again, it implements a graph database that implements a subset of Cypher. That's a Neo4j query language. He's also going to present it, right? So I won't go too much into that. He's just been in the Neo4j conference in Germany where they actually saw it and invited him to showcase what he did. He wrote like the entire parser for Cypher and adapted it to his module. Really cool. And then there was a time series aggregation engine, a Python function execution, stats D reporting done by someone at Redis Labs, time decaying, and I wanted to add a dehydrator, but I don't know how to describe it, Adam. So there's this thing called a dehydrator, which it's a sort of a queue thingy. And Adam the guy who wrote it, will speak as well, and maybe he can go into that a bit. So what's next for modules? We're going to release them as part of Redis Enterprise product within a few months. We're going to pre-bundle the search, the JSON, secondary, and ML, but we're going to, probably allow users to upload their own modules or open source versions of the modules into the enterprise cluster at their own risk. And then there's a bunch of stuff. I don't have time, so I'll go over it really quickly. Once Redis 4.0 stable is released, the API is like 99% stable, but far from complete. So we want to improve the low-level API, add key space iteration, a bunch of other stuff that will make the API even more flexible. We want to do thread-safe operation, which will allow the threads not to just enqueue CPU-intensive work on a background thread and return to the main thread, but actually invoke Redis commands and manipulate data structures directly from other keys, which is, if you know the Redis way and the way things work in Redis, is going to be a revolution, because think about it, if you have like to union two huge sorted sets, now you can do that without blocking Redis. It's going to revolutionize Redis, I think. And again, you could actually lock a key, like a row level lock, and do your stuff, which would be really cool. Another thing we want to do is to add hooks, which will allow you to actually replace commands or override them. You could add authentication, encryption, or just, like in the case of what Yossi showed with CRDT, basically replace the entire implementation of a command with something new. And another thing is to allow clustered modules. Now, even though modules can run on a cluster, imagine in the use case of a search engine, you actually need to query many shards and have some sort of coordination. And right now, this is done on the client side, but we want it to be part of the cluster itself, and that's also something that we want to work on. And it will allow things like search engines to really, really scale. And again, one of these things is going to allow this queue to become part of Redis and become a module, because the API is going to support everything it needs. If you want to write a module, it's really easy. We have resources on that. The best place to start is, there are two best places to start. One is the actual Redis code base. There's a folder called modules with a bunch of documentation, which is really good, and a bunch of examples. And there's also the Redis Modules SDK that we're using as part of our work in Redis Labs, which includes also, on top of the documentation, also some utility libraries that make your life easier, and the project template with makefiles and everything, and that's also useful. And that's about it. Thank you. Questions? Yes.
How do I know if a specific module is cluster ready?
The question is, how do you know if a specific module is cluster ready? That's a good question. Right now, there's no way to know. It should be written in the documentation of the module, but modules can actively block themselves from being loaded into a cluster. But we'll get to maybe refining this experience. Anyone else? Yeah.
How do I discover modules? How do I load them into Redis? Is there a marketplace searching?
All right. So we have the sort of marketplace that's redismodules.com, the modules hub that we've designed. Salvatore is going to add a modules page to Redis.io that you can, just like you're looking for clients there, you can look for modules. Right now, there's nothing like provisioning systems. There's no NPM for modules. We actually want to build that. But if someone else wants to build that, it's going to be super cool as well. You can just, you have to install it by source and compile it. But the cool thing is that keeping in the Redis tradition, module developers try not to have any dependencies. Basically, if you have a compiler and make, you can compile the module. It doesn't require linking against Redis or anything special. Yes?
One module by accident overrides some data from other module?
You mean a command?
A command which will...
No, we protect against that. You can't register the same command twice.
I'm sorry, not the command. The data which is being saved.
No. When you have a custom data, sorry, the question is whether one module can override stuff by another module. So when you persist stuff from a module, the data blob that you've persisted gets the ID of the module prepended to it, and then Redis, actually the whole RDB loading process will just not work if the module is not loaded into Redis at this entire moment, in this exact moment. Yes.
Regarding the to-do, you talk about making the threads.
Yeah.
There is an API for that because modules currently are blocking the operations. secondary indexes on the big sets might take some time.
So even right now, they're not blocking the operation because you have the asynchronous API to perform background tasks. The way we're solving this it's not implemented yet, but the way we plan to solve it in the secondary index is basically that you get a cursor and you read from it bit by bit. But the ETA for completely multi-threaded support in Redis is Redis 4.2, which will probably be towards the end of 2017. Yes?
You mentioned that the hackathon, somebody wrote a module in Rust. And are there other languages that are supported, other than Rust and C?
The question was about other language supports for modules. So Rust has a pretty straightforward C binding. So there's no special requirements to do that. The guy just wrote that because binding is really easy. I personally wrote a bridge for Go. One of the projects was a bridge for Python. It's pretty trivial, but it requires some work. So far, the only supported are Go and Rust. And Python, sorry.